Welcome, Form 4, Physics, Topic 6, Optics, Notes, Lesson 2. We continue from Lesson 1. I said in convex mirror, if you have a convex mirror, the one I highlight, is part of a sphere, and that sphere must have the center of curvature C. And then I said in the previous lesson, the distance between the C and the vertical line representing the convex mirror is R. The distance between the C and the vertical line representing the convex mirror is R. And then we have this horizontal line passing through the C is called the principal axis. And we have a point on the principal axis called the focus point or focal point, symbol F. And the distance between the focus point F and the vertical line is F, which is small f, focus length or focal length. And I said that this R radius is 2 times of the focal length, which means the focal point divide the R into 2 equal parts. So from F to mirror is the focus length, and from F to the C also focus length. Because of that, the point C, center of curvature, we also can label as 2 capital F. Okay, this is all was in the previous lesson. Today's lesson is we are going to look at the 3 properties of light ray for the convex mirror. The 3 properties of light ray for convex mirror. The first property is, if I take a light ray that is parallel to the principal axis, and this is a light ray that is parallel to the principal axis. And keep in mind, I draw the light ray only until the vertical line. So this light ray, when reaches the mirror, it is going to get reflected. It's going to get reflected. Mirror, reflect from where? For a light ray that is parallel to the principal axis, it will get reflected as though from the focus point. So what I do now, I take this out, I go to the focus point, this is our focus point, and then I'm going to draw broken lines until this point. The broken line shows as though now this light ray is going to get reflected. So the first property is a light ray that is parallel to the principal axis will get reflected from the mirror as though it is coming from the focus point. So the dotted lines here means as though. Not necessarily up. The light ray can also be down. I can draw here a light ray that is parallel to the principal axis. It will get reflected as though from F. So I'm doing broken lines until here. Now it gets reflected. This is the first property. This is our first property. I've done it twice. Any light ray that is parallel to the principal axis, it gets reflected as though from F. Any light ray parallel to the principal axis, it gets reflected as though from F. This is the first. Now we look at the second property. The second property is the inverse of the first property. Okay, which is any light ray as though approaching F. Now this is approaching F. Any light ray as though approaching F, it will become parallel. Parallel to what? Parallel to the principal axis. I repeat, any light ray as though approaching F, after reaching the mirror, reflect and become parallel to the principal axis. Of course, I have to rub this off. I have to draw this back again. This is not parallel to this. Okay, I can draw anywhere. I can draw below also. You watch. Any light ray, again the second property, any light ray that is approaching as though approaching F, it will become parallel. Parallel to what? Parallel to the principal axis. So the second property is the opposite of the first property. First property, parallel, it will diverge as though from F. Parallel, diverge or reflect, same thing. Reflect as though from F. The second property, if the light ray as though approaching F, it will become parallel. A light ray as though approaching F, after reflect, it will become parallel. Okay, this was our second property. Now we shall look at the third property. The third property is actually quite simple. In this lesson, we are only learning the three properties. And the final third property is any light ray that's approaching the C, the center of curvature. You watch, I'm going to... Let me use a black pen. I'm going to draw broken lines, okay? I have a light ray. The third property. Any light ray as though approaching the C, it will come back the same path. So if I were to draw, let us say I'm drawing another ray. I have to draw the broken lines. You watch this. The third property. Any light ray as though approaching the center of curvature, it will come back the same path. So if here, in the original one, any light ray, okay, I put arrow, as though approaching the center of curvature C, it will come back on the same path. That's it. So the three properties, what was it? Parallel to principal axis, it will reflect as though from F. Parallel to principal axis, reflect as though from F. Second, as though approaching F, it become parallel. Third, any light ray as though approaching C, it doesn't reach C, because once reaching the mirror, it must reflect back. So any light ray as though approaching C, it will come back the same path. So that was the three properties of light ray. To get a better understanding, watch the video more than once. On the third lesson, I'm going to teach the properties of image by convex mirror on the third lesson. Thank you.